Hello everyone, my name is Xiaoqiong Li. I'm glad to have this opportunity to tell you about my research at here. I am a postdoctor of the Institute of Physical and Chemical Technology of the Chinese Academy of Science. Today, my topic is quality and economic analysis of transcritical carbon dioxide heat pump in blanching of Penaeus chinensis. The contents include three sections. Section 1 is the research background and significance. As we all know, shrimps are very popular all over the world. It not only tastes delicious, but also contains a series of nutrients beneficial to human body, such as protein, vitamins, and exoskeleton. However, if the shrimps are not treated or handled improperly, they will turn black and deteriorate, which will affect the quality and economic benefits of the shrimps. The main reason why shrimps turn black is that the shrimp body contains tyrosines, which will promote the tyrosine in shrimp body to produce melanin through a series of biochemical reactions. The left figure shows the formation of melanin. Therefore, tyrosines in shrimps must be inactivated to prevent the shrimps from turning black and ensure the quality of shrimp products. Blanching is an important measure to solve the above problems. The traditional blanching process is shown in the figure. Live shrimps enters the fuel oil blanching machine after being cleaned, blanching, and cooling. The water is heated to 100 centigrade through fuel oil, and the waste gas is directly discharged into the environment. It causes high energy consumption and pollution. Taking into account the characteristics of environmental protection and energy saving, the transcritical carbon dioxide heat pump as an alternative heat source was proposed, which could provide hot water of 90 centigrade for blanching. However, here are two questions. One, whether the 90 centigrade blanching can obtain the original product standard. 2. How the energy saving and environmental protection effect of a transcritical carbon dioxide heat pump blanching process is. Aiming at these two problems, this paper selected Penaeus chinensis as the research object and mainly discussed the following two aspects. One is the product quality analysis of blanching shrimps, and the other is the economic analysis of the transcritical carbon dioxide blanching process. Firstly, the quality of 90 centigrade and 100 centigrade blanching was analyzed respectively from the two aspects of component analysis and sensory evaluation, and the feasibility of 90 centigrade blanching was determined. The Penaeus chinensis with similar size and quality were selected as the comparative analysis objects. First, we need to determine the inactivation time of the tyrosines. A tyrosines test kit that can be used for muscle tissue detection was adopted, and the enzyme activity unit of tyrosines is calculated according to the enzyme activity formula provided by the test kit. The results showed that when the blanching temperature was 100 centigrade, tyrosines was inactivated at 150 seconds. When the blanching temperature was 90 centigrade, it needed 210 seconds. Then we researched the nutritional components of Penaeus chinensis. The standard acetylene solution was prepared, and the standard curve was drawn. The experimental results showed that when the blanching temperature was 100 centigrade, the content of acetylene is the highest in 240 seconds to 360 seconds. When the blanching temperature was 90 centigrade, the content of acetylene was the highest at 270 seconds to 390 seconds. Next, the difference of color and texture of blanched Penaeus chinensis products were analyzed. In the color difference analysis, the colorimeter instrument was used to test the values of L, A, and B respectively. Notedly, L, A, and B represent the brightness, redness, and yellowness of food respectively. The change trend of L and A are close to that of acetylene content. These changes are related to the changes of muscle protein structure. It can be seen from three figures. There was no significant difference between 90 centigrade and 100 centigrade blanching. In the texture analysis, with the decrease of blanching time, hardness, chewability, and elasticity increased. Moreover, with the further increase of blanching time, the degree of protein denaturation increased and the elasticity decreased. There was no significant difference between 90 centigrade and 100 centigrade blanching. Last, sensory evaluation was calculated. Sensory evaluation can analyze and describe the sensory characteristics of food, such as smell, taste, and touch, which can intuitively reflect the tester's acceptance and preference for food. In this paper, 10 healthy people aged 20 to 35 with normal 5 senses were selected to evaluate and analyze the blanched products at 90 and 100 centigrade respectively. The results showed that the effect of 180 seconds is best when blanching at 100 centigrade, while blanching at 90 centigrade. 240 seconds is the best, which is also in line with the actual process. Therefore, the feasibility of blanching shrimps with hot water at 90 centigrade was proven, and the quality was better than that of blanching shrimps with hot water at 100 centigrade. In the section 3, the economic analysis of transcritical carbon dioxide heat pump blanching was presented. Firstly, in order to improve the outlet water temperature as much as possible and ensure the stable operation of the system under the outlet water condition of 90 centigrade, we explored the effects of inlet water temperature, expansion valve opening, inlet water flow rate on the outlet water temperature of the system. Under different inlet water temperatures, with the decrease of the expansion valve opening and inlet water flow rate, the outlet water temperature of the heat pump will gradually increase. In addition, the higher the inlet water temperature, the higher the outlet water temperature. The maximum outlet water temperature of the system in this paper could reach 95.6 centigrade. But the system will shut down soon. After many tests, the inlet water temperature in this test was controlled below 40 centigrade, and the maximum temperature is no more than 43 centigrade. In the equipment, the test conditions as follows. The blanching experiment was carried out simultaneously with the food processing plant. The experiment was conducted for half an hour, and the system used a clip-on ammeter to measure the compressor current every 5 minutes. The results showed that the maximum heating capacity of the system was 43.77 kilowatt, and the maximum COP could reach 3.44. Finally, we analyzed the economic condition of the two blanching modes. The analysis standard is calculated according to the average daily blanching 3,000 kilograms of Penaeus chinensis in factory. The results show that the cost of blanching Penaeus chinensis with transcritical carbon dioxide heat pump can be saved by 0.028 yuan per kilogram, a decrease of 65%. The economic benefit was remarkable, and there is no black smoke in the whole processing process. Converted into standard coal, for each kilogram of carbon dioxide blanching product, the emissions of carbon dioxide, sulfur dioxide, and nitrogen oxide were reduced by 75%, 75%, and 83% respectively, with remarkable environmental benefits. That's all for my report. Thanks for your listening.